next talk is entitled Effects of Mixing Elemental Sulfur with Demethylation Inhibitors, DMI and Quinone Outside Inhibitors on the Management of Late Leaf Spot and Rust of Peanut, Arachis Hypogaea.
Hello, again, my name is Kenyanna Taylor. I am a master's candidate at Valdosta State University, where my advisor is Dr. Emily Cantonwine, and I will be talking about the effects of mixing elemental sulfur with DMI and QoI fungicides and the effect on the management of late leaf spot and rust of peanut. So my presentation outline, I will go over, in the introduction, I will go over both of the diseases, my basis of my current study, which will have some literature, my research, which will have my questions and my hypotheses, and I will also go over my methods, results, discussion, and conclusion. So just going over the first disease, we have Nothopassalora personata, which is the fungal disease of late leaf spot. It is a disease that favors wet weather from rain, infrequent dew, or high humidity. This disease causes yield loss from defoliation of diseased leaflets, and the symptoms are circular chocolate spots, which you can see in these red circles on both sides of the leaves. So the next disease, Puccinia arachidis, is the fungal agent of peanut rust. This disease appears orange, but in severe cases, the infected area can look burned. Some signs of infection, or the signs of infection, are marked by the formation of pustules, which we can see in this picture over here, that erupt from the lower leaf surface that produce orange to brown spore masses. These pustules are commonly found on the bottom leaf surface, but they may protrude to the top side. And infected leaves will tend to remain on the stem, but severe defoliation can occur in severe cases. So here I just have the two life cycles of the fungal agents. Late leaf spot, which is the life cycle on the left, occurs annually in the southeast, where the disease overwinters in the fields. But peanut rust, which is the life cycle on the right, occurs occasionally in the southeast. This disease is brought to North America from South America, Central America, and the Caribbean by hurricanes. So going to my basis of my current study, studies have shown that mixing synthetic fungicides with sulfur has greater control over the severity for brown rot in peach and powdery mildew in nectarines. So the first study was conducted by Ravini, and he based his study in Israel, where QoI fungicides were mixed with reduced rates and full rates of sulfur. These tank mixtures showed an enhanced inhibitory effect against powdery mildew when compared to QoI fungicides alone. In the next study, conducted by Holman Schnabel, they studied the effect of sulfur propionconazole mixtures on brown rot of peach in orchards of the southeastern United States. The results showed that the sulfur mixtures provided the best control for propionconazole resistant isolates. The results also suggested that the addition of elemental sulfur to a DMI is a relatively inexpensive means to improve brown rot control. So recently, there has been an effective mixing sulfur with DMI fungicides, Colbert et al. In 2019. This paper showed an improvement in late leaf spot control with the addition of elemental sulfur to DMI fungicides. And this study was conducted in Tifton, Georgia, again on late leaf spot. So just to go over the graph, you have 3 treatments: no DMI, ciprochromazole, and prothioconazole, tebuconazole, and I'm just going to refer to these as Alto and Provost. And I have sulfur, no sulfur, which is the blue, and sulfur added, which is the orange. So looking at the graph and looking specifically at AUDPC statistics, when sulfur was added in all treatments, there was a significant decrease, and this is signified by the asterisks, and this is just a significant difference between sulfur and no sulfur. And this also showed the significant difference, shows a decrease in area under the curve, and this decrease was similar in reduction amount for each treatment, as we can see here. The next set of statistics we're going to be looking at is the final percent defoliation, and the same pattern holds. You have the 3 treatments, and then you have no sulfur and sulfur. So at the end of the season, the blue bars, which are the no DMI sulfur treatment only, which is the Alto and Provost, you see here, here, and here, had similar percents of defoliation. By adding sulfur to Alto and Provost, we saw a significant difference in the final percent defoliation, again, represented by the asterisks. We did not see this in the no DMI treatment. At the end of the season, sulfur can help these fungicides that had low control on late leaf spot increase its efficacy towards the fungus. So now we're going to get into my research. I had 2 questions to see if adding elemental sulfur to a QoI with poor leaf spot control would show an increase in fungicide efficacy as seen for the DMI. My second question, to see if sulfur mixtures enhance DMI and QoI efficacies for rust. And the corresponding hypotheses, the QoI fungicide, when mixed with elemental sulfur mixtures, will perform better than the QoI alone. And the second, adding sulfur will enhance DMI and QoI efficacies for rust. Moving on to my methods, I conducted a field study in Tifton, Georgia in 2020 with 4 replications of the following treatments: non-treated control, elemental sulfur, tebuconazole, which was my DMI, sulfur mixed with my DMI, azoxystrobin, which was my QoI, and sulfur mixed with the QoI. I used the cultivar Georgia 06G. So just getting into how I assess late leaf spot. Late leaf spot severity was assessed using the Florida 1 to 10 scale, and assessments were made weekly beginning 112 days after planting until harvest. The Florida 1 to 10 scale takes into account frequency of late leaf spots and defoliation of the canopy. So rust severity was assessed using a modified ICRISAT 1 to 9 scale. Assessments again were made weekly 112 days after planting until harvest. The ICRISAT scale is based on frequency and location of rust pustules and the necrosis of the plants. And I use this diagram for assessments. Methods continued. For the analytics, I use SPSS, where I conducted GLM and 2 key post hoc tests for each assessment date for the treatments. And I created disease progress curves based on means and standard deviations. So now we're going to get into my research, starting with late leaf spot, just going over the pattern at the bottom for the treatments. The black lines are untreated control, and then this is sulfur only, which is the dotted line. For the DMIs, I have them in blue. DMI plus sulfur is the dotted line. DMI alone is the solid line. And for the QoIs are in red. The QoI only is the solid line, and the QoI plus sulfur are the dotted lines. So every treatment that had sulfur has dotted lines, just to clarify. So looking at these statistics, there was not a lot of difference between treatments until after 125 days after planting. There was a lot of variation early on. By the end of the experiment, looking at 140 days of planting after planting, the Florida 1 to 10 mean scale rating for the QoI plus sulfur and the DMI plus sulfur performed significantly better than the 2 fungicides alone. Confidence in the untreated and sulfur only was lost 133 days after planting due to rust severity. Sulfur has a similar effect on QoI as it did on the DMI, and that's what these results show. So going on, looking at my peanut rust data, looking at the disease curve, I have the same pattern for the treatments at the bottom. So we're just going to get into it. The untreated and sulfur treatments had the highest rust rating over the entire screening period and did not differ from each other on any assessment date. Again, looking at the last day, there was no significant difference between the DMI fungicides. So adding sulfur to the DMI fungicides, we did not see a significant difference. Adding sulfur to the QoI fungicides, we did not see a significant difference between QoI alone and the QoI plus sulfur. But we're going to look at the significances. So looking at where the QoI treatment alone performed significantly better than the QoI, than the DMI alone. And then we see the same pattern. The DMI, the QoI plus sulfur alone performs significantly better than the DMI plus sulfur alone. Adding sulfur did not significantly reduce except for this final planting date. So going into my discussion conclusion, we're going to talk about late leaf spot first. Sulfur improved the DMI fungicide management of late leaf spot in this study, and these results do support Colbreth et al. 2019 results. Sulfur did improve the QoI fungicide management of late leaf spot in this study, which supports my first hypothesis. The QoI fungicide, when mixed with elemental sulfur, performed better than the QoI alone. And this proves that sulfur improves another class of fungicides. Now we're going to go to the discussion conclusion for peanut rust. Sulfur did not improve DMI or QoI fungicide management of peanut rust in this study, which does not support my second hypothesis that adding sulfur will enhance DMI and QoI efficacies for rust. Sulfur alone did not appear to have much of an effect on peanut rust in this study. And this is the first experiment comparing the efficacy of sulfur mixtures on a rust pathosystem. Getting into some additional research that I will be conducting. I will be conducting another field experiment. Well, I will repeat the collection process of central and lateral branches for late leaf spot counting and defoliation assessment. But for additional research, I will be looking at what is the cause of the phenomena occurring in the field. Specifically, what is sulfur's role? So there could be two possibilities. One is that sulfur is helping the plant. It may be helping the plant hold on to its leaves longer or helping to green up the plant. Or it could be decreasing the fungus ability to affect the plant, or both. I don't know. So to delineate sulfur's role, first starting with sulfur's effect on the peanut plant, I will be collecting those central and lateral branches during my next field experiment and assessing for not only defoliation, but also for late leaf spot counts. To see the effect of sulfur on the fungus Nothopassalora personata, I will be conducting an amended media study where I will be looking at the effect that these 6 treatments that I used in my field experiment may have on fungal growth. So we have a lot to do this year. And thank you so much. I would like to thank Valdosta State University, especially my advisor, Dr. Emily Cantonwine. I would like to thank the University of Georgia Tifton campus, especially Dr. Albert Colbreth. And are there any questions?
So thank you, Kenyanna. We have time for questions, and we have a couple. Here's one right now coming from Abraham Fulmer. Question is, if a grower decides to spray sulfur one time in the season, would you recommend mixing with a DMI or a QoI? And how would you answer this question based on your results?
So looking at my results, I would definitely use a QoI because it had the lowest. It may not have been significantly different from the DMI, but it was the lowest in the Florida 1 to 10 scale over time.
Next question is from Dr. Tim Berteman. How much was fungicide resistance involved in the poor performance of the fungicides without sulfur? Do you think sulfur will help fungicides overcome resistance? So how much was resistance involved in the poor performance? And do you think sulfur will help those fungicides overcome resistance?
My research did not look specifically at resistance. I was mainly looking at the efficacy that was lost, hopefully to be gained. But I really don't know the answer to that question. But what was the second question? The second part to that question.
Second part is, do you think that sulfur will be a part of a solution for helping fungicides like this to overcome resistance?
I do, because sulfur is a protectant. It would definitely help to decrease the resistance over time that Nothopassalora personata and some other fungi may have to these single mode of action fungicides.
Okay, great. Thank you very much. And there's not appeared any more questions, so thank you for your presentation.
Thank you.